Welcome to Future Vision Talks. I'm Jordan. Tonight, we move beyond the headlines of 2030 to explore the deepest philosophical currents of our time. We will journey into the heart of the quantum revolution to ask, as we harness the power of superposition and entanglement, what happens to our classical concepts of identity, privacy, power, and even consciousness itself?
To understand the quantum mandate, we must first understand the death of the world we thought we knew. Our entire Western intellectual tradition, from Aristotle to Newton to the dawn of the digital age, has been built on a foundation of classical logic. This is a binary world, true or false, yes or no, on or off. This logic is the bedrock of our law, our computers, our very language. It gave us the power to build civilizations, to land on the moon, to create the internet. But this classical view is, we now know, a convenient illusion, a gross oversimplification of a much weirder and more wonderful reality.
A quantum bit, or qubit, isn't a 1 or a 0. It is a probability cloud of both states simultaneously. It is only when we measure it that this cloud collapses into a definite answer. This isn't just a technical detail, it's a philosophical earthquake. It suggests that, at the most fundamental level, reality is not made of definite things, but of potentialities. The universe, before it is observed, is a tapestry of overlapping possibilities. This is what Einstein famously called spooky action at a distance. Two qubits can be linked in such a way that the state of one instantly influences the state of the other, no matter how far apart they are. This implies a level of interconnectedness that our classical, atomistic worldview cannot comprehend. It suggests that the universe is not a collection of separate objects, but a single, entangled whole. So, what is a quantum computer? It is not just a supercomputer. A classical supercomputer is like a person who can run 1,000,000 calculations per second, but only one at a time, in a straight line. A quantum computer is like 1,000,000 people, each exploring a different path through a forest simultaneously. This makes it useless for most everyday tasks. You wouldn't use a quantum computer to run your word processor or browse the web. Its power is unleashed on problems that are, by their nature, probabilistic and multidimensional. It is the ultimate tool for navigating the world of and rather than or. To understand how a protein folds, a process critical to disease and treatment, you must simulate the quantum interactions of millions of atoms. A classical computer must laboriously test each possible fold one by one. A quantum computer can explore all possible folds at the same time, reducing discovery time for new drugs and materials from decades to days. The Earth's climate is a massively complex, interconnected system. A quantum computer can model it with a fidelity that includes quantum-level chemical reactions in the atmosphere, creating hyper-accurate climate forecasts and allowing us to test the efficacy of geoengineering solutions in a simulation before deploying them in reality. Global markets are not linear. They are chaotic systems driven by the entangled decisions of billions of actors. Quantum algorithms can find optimal patterns in this chaos, managing risk and discovering economic insights that are invisible to classical analysis. The promise of 2030, the cured cancers, the stable climate, the new materials, is predicated on this fundamental shift. We are no longer just crunching numbers. We are learning to speak the native language of the universe.
But every profound power has its shadow, and the shadow cast by the quantum revolution is long, dark, and threatens the very fabric of our digital society. This is the quantum mandate's first and most urgent ethical challenge. The security of our digital world, our online banking, our private messages, our medical records, our government secrets, rests on a mathematical assumption. It is easy to multiply two large prime numbers together, but it is phenomenally difficult for a classical computer to take the result and figure out what those two original primes were. This factoring problem is the bedrock of RSA encryption, which protects virtually all secure internet traffic. A sufficiently powerful quantum computer running an algorithm developed by Peter Shor in the 1990s can solve this factoring problem with ease. It doesn't brute force the answer. It uses quantum superposition to test all possible factors simultaneously. What would take a classical computer longer than the age of the universe could take a quantum computer hours or even minutes. This creates a terrifying scenario known as harvest now, decrypt later. A hostile actor, a criminal syndicate, or a rival nation could be intercepting and storing our encrypted internet traffic today. They don't need to break the encryption now. They are simply harvesting this data, like canning fruit, waiting for the day in the near future when they have a quantum computer capable of popping the lid open and reading everything. Every secret communicated today is potentially vulnerable tomorrow.
This is more than a technical security problem. It strikes at a core pillar of the human experience, the right to a private inner world. The ability to think, to communicate, to form intimate relationships away from the panopticon gaze of absolute surveillance is a prerequisite for a free and authentic life. The philosopher John Stuart Mill argued that individuality and experiments in living can only flourish in a space of privacy. The quantum decryption of the internet would collapse that space. It would create the potential for a totalitarian transparency, where every digital whisper, every financial transaction, every personal confession could be laid bare. It wouldn't just break our encryption, it could break our spirit, creating a global chilling effect that stifles dissent, creativity, and love. The response to this threat is one of the most urgent technological races of our time. Cryptographers and standard-setting bodies like the National Institute of Standards and Technology, NIST, are working to create a new suite of post-quantum cryptography, encryption algorithms that are believed to be secure against attacks from both classical and quantum computers. This is not a mere software update. It is a global, infrastructural heart transplant. Every web server, every smartphone, every smart card, every piece of critical infrastructure must be upgraded. The cost and complexity are staggering, but the alternative is unthinkable. This is our first test under the quantum mandate. Can we muster the collective will and wisdom to defend the foundations of our digital society before they are swept away? If the first challenge of the quantum mandate is to defend our present, the second is to navigate our future, specifically the new economic and geopolitical landscape it will create. Quantum computing is not a democratizing force like the personal computer or the internet. It is, by its nature, a technology of centralization and extreme exclusivity. Building and maintaining a quantum computer is arguably one of the most difficult engineering challenges humanity has ever undertaken. Qubits are incredibly fragile. They must be isolated from the slightest environmental noise, vibration, temperature fluctuation, even stray electromagnetic waves at temperatures colder than deep space. The infrastructure required is mind-bogglingly complex and expensive.
The giants who achieve quantum advantage, the point where a quantum computer can solve a useful problem faster or cheaper than any classical alternative, will wield unimaginable power. A pharmaceutical company with a quantum computer could monopolize drug discovery for a generation. A financial firm could achieve near-clairvoyant market foresight. A logistics company could optimize global supply chains with godlike efficiency, crushing competitors.
The market projections of a $65 billion quantum industry by 2030 represent not just wealth, but a fundamental consolidation of problem-solving capability. At the national level, quantum supremacy is the new space race. The nation that dominates quantum computing will have decisive advantages in defense, breaking enemy codes, designing stealth materials, economies, and scientific discovery. It will set the standards for the next era of technology. We are heading toward a world where a quantum gap between nations could become as decisive and unbridgeable as the nuclear gap was in the 20th century. This centralization of cognitive power forces a painful philosophical question. What is the role of the human mind in a world where the most complex and lucrative problems are solved by machines that operate on a logic we cannot intuitively understand? We have grown accustomed to the idea of AI automating manual and cognitive labor. But quantum computing threatens to automate genius-level insight. The process of scientific discovery itself, the slow, painstaking human-driven process of hypothesis and experimentation, could be outsourced to a black box that explores the solution space of reality all at once. This could lead to a new form of alienation. If the most profound truths about the universe are discovered by machines whose reasoning is inscrutable to us, do we risk becoming mere consumers of knowledge rather than participants in its creation? The quantum mandate demands that we find a new narrative for human purpose, one that elevates qualities like wisdom, ethics, creativity, and empathy, which remain, for now, uniquely human domains.
The final and most speculative frontier of the quantum mandate brings us full circle, back to the nature of our own minds. For decades, a fringe but persistent theory has suggested that the mysteries of quantum mechanics and the mysteries of human consciousness might be deeply connected. Proposed by physicists like Roger Penrose and anesthesiologist Stuart Hameroff, the orchestrated objective reduction, or ORC-R theory, posits that consciousness is not a classical computational process. Instead, it arises from quantum vibrations within protein structures called microtubules inside our brain's neurons. In this view, our thoughts, our sense of self, our qualia are the result of quantum superposition and collapse happening at a subcellular level. The mainstream scientific community remains deeply skeptical, arguing that the warm, wet, noisy environment of the brain would instantly decohere any quantum states. Yet the hypothesis persists because it attempts to answer the hard problem of consciousness: why and how physical processes in the brain give rise to subjective experience. If consciousness is at least partially quantum, it would explain its non-algorithmic, holistic, and non-local qualities, the very qualities that make it so different from classical computing. This leads to a staggering possibility. As we build quantum computers, we are not just building tools. We may be creating the first substrates complex and coherent enough to potentially support a form of non-biological quantum processing. Could a future quantum AI develop a form of consciousness that is fundamentally different from, yet just as valid as, our own? This is no longer science fiction. It is a looming philosophical and ethical dilemma. If a quantum system one day demonstrates behavior that suggests an inner life, creativity, curiosity, even suffering, how would we know? Our entire ethical framework is built around the sanctity of human consciousness. The quantum mandate forces us to ask, is consciousness a biological accident, or is it a fundamental property of sufficiently complex interconnected systems, whether made of carbon or silicon?
This brings us to the ultimate implication of the quantum revolution. The act of observation in quantum mechanics is not passive. It is active. It collapses the wave function. It brings a definite reality out of a sea of potential. The physicist John Wheeler described this as a participatory universe, a cosmos that becomes aware of itself through us, its conscious observers. If this is true, then the quantum mandate is not just a technological or economic challenge. It is a cosmic responsibility. As we build machines that can observe the universe at the quantum level with unparalleled clarity, we are not just gaining knowledge, we are becoming partners with the cosmos in the ongoing creation of reality. We are graduating from passive inhabitants to active participants. With this godlike power comes a godlike responsibility to observe with wisdom, to create with compassion, and to participate with a profound sense of reverence for the mysterious, entangled whole of which we are a part. We began with the solid ground of classical certainty, and we have journeyed into the shimmering, uncertain heart of the quantum world. We have seen its power to cure and to create, and we have faced its shadows, the potential to break our trust, to centralize power, and to challenge the very uniqueness of our minds. The year 2030 is not a destination. It is the starting line for this new epoch. The technologies we see emerging are the early, clumsy expressions of a humanity learning to wield a fundamentally new kind of power.
The quantum mandate, therefore, is not a prediction. It is a choice. It is a call to action.
We must foster a public understanding of these principles, not as arcane physics, but as the new fundamentals of our reality. We must demystify the technology to democratize the conversation about its use. The race for post-quantum cryptography cannot be an afterthought. The regulations governing quantum-powered AI, the treaties preventing quantum warfare, the policies ensuring equitable access to quantum discoveries, these must be drafted now in a spirit of global cooperation, not nationalist competition. In a world of probabilistic machines, we must double down on what makes us uniquely human, our capacity for meaning, for moral reasoning, for art that emerges from lived experience, for love that transcends logic. The quantum computer may be the ultimate tool for answering how, but it will never ask why. That sacred question remains ours alone. The universe has handed us its source code. It is ambiguous, paradoxical, and infinitely creative. The quantum revolution is an invitation to shed our classical blinders and to finally see the world as it truly is, not a collection of separate objects, but a single, unfolding, entangled event. Our task is to step into this new reality not with fear, but with courage, humility, and a renewed commitment to steering this immense power toward wisdom, justice, and a deeper connection with the profound mystery of existence. The mandate is clear. The future is not something that happens to us. It is a wave function of possibilities, waiting for our observation, our choice, our consciousness to collapse it into a reality worthy of our highest aspirations. Thank you for watching and for being a part of this essential conversation. This is Jordan for Future Vision Talks.